Hi everyone, I'm here to solve LeetCode problem number 328, odd-even linked list. Let's read the problem. Given the head of a singly linked list, group all the nodes with odd indices together followed by the nodes with even indices and return the reordered list. The first node is considered odd and the second node is even, and so on. Note that the relative order inside both the even and odd groups should remain as it was in the input. You must solve the problem in O of 1 extra space complexity and O of n time complexity. Okay, let's take a look at what's going on in this problem. So it tells you in the problem statement right away that the first node is considered odd and the second node is considered even. So all the odd nodes are 1, 3, 5, and the even ones are 2, 4, and then once you construct a new linked list, all the odd ones are grouped together first, followed by the even ones. 1, 3, 5, 2, 4. Let's take a look at this example, right? The odd nodes are 2, 3, 6, 7. 2, 3, 6, 7. And the even ones are 1, 5, 4. 1, 5, 4. So in the end, you get 2, 3, 6, 7, 1, 5, 4. Okay, this problem, visually speaking, understanding the problem is not hard, but this can be a little bit intimidating in the beginning once you look at the problem, but it's not a hard problem. You know, the basic idea is that you go through the you have a head pointer that points right here. You set another head pointer that points to the start of the even nodes, and then you use an odd and even pointer to go through the linked list and construct a list with only the odd nodes, another list with only the even nodes, and then you join the two linked lists together into one, and that is the answer. So it's not a hard problem. Let's do it. And by the way, the algorithm I'm about to demonstrate, I want to give credit to Nick White from YouTube. Great channel. I'm learning from him, so this algorithm is mostly due to his genius and his thought and care. So thank you, Nick. Let's take a look at the constraints. The number of nodes in the linked list is in the range 0 to 10 to the 4th. So you know that the number of nodes in the linked list that you're given could be nothing, or it could be the number of nodes could reach as high as 10 to the 4th, right? And so because it's possible that we're given an empty linked list, this is a case that we have to treat. We have to treat this special case, okay? And minus 10 to the 6 is less than or equal to node dot val, which is less than or equal to 10 to the 6. Basically, the values themselves can range. They have a pretty extreme range. They can go from anywhere from negative 10 to the 6 on the low side, and on the high side they can be as big as 10 to the 6. And this constraint is not as important as this one, the first one, because we really need to treat this special case right here. This topic is linked list. It's definitely a linked list problem, and it's been a very long time since I've done a linked list problem, and so this is a good practice problem. So let's take a look at the approach. Treat. I think that's how you spell treat, right? Let me just take a look. Treat. Yeah, that's how you spell treat. Sorry. Had like a brain malfunction right there. So treat the special case where you are given an empty linked list. Define pointers odd even and even head and assign them to the right values. So this is what I was talking about. We're going to have an odd and an even pointer to do the work, and then we already have the head pointer that's pointing to the start of our given linked list. So the head pointer automatically is the head of the start of the linked list that will hold the all the odd nodes, and we have an even head that will point to the starting node that will chain together all the even nodes in the linked list. Do a while loop as long as even and even dot next does not equal none. Update the nodes in the following order: odd dot next, odd, even dot next, even. Set join the two, join the even, the odd and even link lists. Assign odd dot next to even head, right? Because the odd, after you do the while loop, the odd dot next is going to be pointing to the last node in the linked list that consists of only odd nodes, and then you join it to the even head, which we set as a placeholder to construct the final linked list that we return. Return head. Okay, let's get started. Treat the special case, right? If head equals none, return none. Define pointers odd, even head, right? So odd equals head, even equals head dot next, and then even head equals even, right? Okay, so then do a while loop as long as even and even dot next is not equal to none, while e does not equal none and e dot next does not equal none. Now you update it in the following order: odd dot next, odd, even dot next, even, right? Odd dot next equals even dot next, odd equals odd dot next, even dot next equals odd dot next, and then even equals even dot next. This is beautiful in the sense that you can use the properties of symmetry to figure this out. But if you have a piece of paper and you drew out these pointers, it would make perfect sense. So the symmetry is that you first do odd dot next, which equals even dot next, then you do odd equals odd dot next, right? This second line is set to the value that you defined in the first line, and basically on the even side you do the same thing. You just flip it. Even dot next equals odd dot next, even equals even dot next, right? So that's beautiful. So then you have do odd dot next equals even e head. Okay, actually I named them O, E, O, O, E, O, E, E, O dot next equals E dot head, and then return head. Let's take a look. Okay. Very good, very good. Let's try one more. And actually, before I try one more time, of course, we know that the TC, time complexity, is O of n, and the space complexity is, of course, O of 1, right? So this got a 66.20% in terms of runtime, and time complexity and 91.61% in terms of memory. Let's just try one more time. Can be a little funky depending on how you run it. Now it's 76 and now it's 91, whatever. But overall, this is a good problem. It's not hard, but it can be a bit intimidating when you first read the problem. I certainly was, but once you understand how it works, it's really not hard. And so you just have to keep practicing, and you get better over time the more you practice. So thank you very much, and I'll see you at the next one.